Good morning everyone. Hope you all are fine at home. So today we will discuss second part of a 6.4 exercise. So there is also further two parts, but here today I will discuss only the condition part. Common root we will discuss in the next video. To find the condition when a relation between the two root is given. So what are the conditions is there when there is a relation in two root is given, like this root is this like square of the other, difference of the other. When this type of condition is there, how you will solve this type of question? Very first thing, if this type of situation occurs, you go with the sum of roots, product of roots, and like if you consider is one root is alpha. Okay, so sum of roots, product of roots, try to eliminate this alpha. So that is a proper procedure. So I have a question in this, like here, prove that the condition that one root of ax square plus bx plus c is equal to 0 may be the square of the other. That means one root, second root is the square of the first one. So you have to prove, your answer will be this. Okay, this is the condition when my one root is square of the other. So in this case, first we consider, let the roots of the equation be alpha and alpha square. Suppose my root of the equation is alpha and alpha square. So first I go with sum of roots. Alpha plus alpha square is equal to minus b by a, and when you multiply this one, product of roots give me alpha cube, that value give me c by a according to my this equation, because sum of roots minus b by a and product of roots give me c by a. Now this is my first equation and this is my second equation. Now my next part is, I have to pick the first equation, because here look at this, b raised to power 3 is there, because I need b raised to power 3. So now I just pick the equation 1 and cube both sides, because I need b raised to power 3. So yeah, we can write it here, cubing both sides of equation 1. So when I take the cube of this equation, both sides, like alpha plus alpha square whole cube and minus b by a whole cube. Now I have to arrange further and try to eliminate alpha to get this condition. So what is left it here? So here a plus b whole cube. So if I have a plus b whole cube formula, so I can apply the formula a cube plus b cube plus 3ab then a plus b. So this is my formula. So I apply it here on the in this left side. So what it will be, like alpha cube plus alpha raised to power 6 plus this is alpha a and b. So this become 3. Alpha into alpha square become alpha cube. Then alpha plus alpha square is equal to minus b cube by a cube. Now if you look at this, if I take here common alpha cube, so 1 plus what is left it here, so that is because if I separate this with 3 and 3, if I don't need to take common, I just separate this one. So this will be alpha cube, and I can write it alpha cube square, or I can take alpha cube common, again 1 plus alpha cube is left inside. So here 3 alpha cube, if I apply the value of alpha cube here, that is c by a, alpha plus alpha square value is minus b by a, this is square, minus b by a minus b cube by a cube. Now here alpha cube value I have c by a plus c square by a square plus 3 times c by a minus b by a is equal to minus b cube by a cube. Now I have to arrange the terms. Here it is a cube, and here if I take the LCM it will be a square. So what I will do, so I will try to take the try to make as a cube. So better I will just cross multiply this a cube on this side, so that will be more easier to me. So if I cross multiply a cube on this side, so 1 is cancelled, so what is left it here, a square c, and here it is left ac square, and a square 1 is left, that is minus 3abc, and here minus b cube is left. So now if I multiply with the negative side all the term, or I just shift this minus b cube on the left side and this negative term on the right side, so what I will get, b cube plus a square c plus ac square is equal to 3abc. So that is exactly my original statement, that condition I want to prove. If this type of question is come, so whatever your root condition is there, you consider sum of root as first equation, product of root as your second equation, and arrange from this equation like that your whatever condition is there, that will be occurred. Sometime condition will be given to you, so in that case you apply the root value in this. So there are some, like first one is, if I have a special, what are the condition of reciprocal roots? Reciprocal root means alpha is equal to 1 by beta. That means alpha beta, if you cross multiply this, alpha beta is equal to 1, that is c by a portion, that is the formula of alpha beta, product of root, that is equal to 1. After cross multiply, my condition is a is equal to c. That means if in my quadratic equation a value exactly is equal to c value, so I can say that my roots are reciprocal to each other. So what are the condition of the zero root? Zero root means if alpha is equal to 0, so that means alpha beta is equal to 0, so only that case numerator like c will be 0, because if a will be 0, that becomes infinite value. So a should not be 0 in this case. If c is 0, so we can say that my product of roots is 0, and this will be 0 root, that is the first case. If only one root is 0, but if in your equation both roots are 0, so in that case sum of roots and product of roots both are 0. That means minus b by a is equal to 0 and c by a is equal to 0. That means b is equal to 0 and c is equal to 0. So that means if in any quadratic equation there is a no value of b and no value of c is there, that means that particular quadratic equation has 0 root. So it should be like this: a x square is equal to 0 when no constant term and no coefficient of x is available. Or we can say that in 0 roots, only in that case our quadratic equation lies is 0 roots, either one root is 0 or either both roots are 0. So what are the condition of infinite roots? So infinite roots mean if this part is 0, a is equal to 0, that means in sum of root when minus b by a you will go, that become quadratic equation, both root will be infinite. If only a is 0, b is available there, so we can say that only one root to be infinite, because c will not be c by 0 and b by 0, so only one root will be infinite. But if b is also 0, so we can say that in quadratic equation both roots will be infinite. So there is some conditions of signs of the root. So what happen in any quadratic equation if positive roots are there? So what is the condition of the positive roots? If positive root is there, that means sum of root and product of root will be positive, minus b by greater than 0, c by greater than 0. But if b and a are of opposite sign, only in that condition minus b by a is greater than 0, and c and a is of same sign, we can say that c and a is greater than 0. So if both will be greater than 0, only in that case we can say that our quadratic equation has positive roots. And what are the conditions of the negative roots? If sum of roots is negative and product of root is positive, that means a, b, c are all of the same sign. If A, B, C all are of the same sign, that means both roots are negative. But sum of root and product of roots has opposite sign. So roots of the opposite sign. So if there is a condition is alpha beta, like product of root is negative, so we can say that C and A are of the opposite sign. So if C and A are of the opposite sign, so only in that case alpha beta is negative, because alpha beta, so if C is negative, A is positive, so that means roots are of opposite sign of that quadratic equation. Roots equal in magnitude but opposite in sign. If whatever roots you have given, length is equal but signs are opposite, so it occurs only in that case alpha plus beta is equal to 0. That means sum of roots is equal to 0 and B is equal to 0. For real solution, sign of A and C should be opposite sign. If you want real solution in your quadratic equation, the A and C sign should be of opposite sign.